Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 3-4 for course 3, graphing in the coordinate plane. In this lesson we want to graph points and use the Pythagorean theorem to find distances in the coordinate plane. Okay, I have my first definition written already. We do have several. A coordinate plane is a grid formed by the intersection of two number lines. And just a quick peek down here, this would be the coordinate plane. This would be a number line right here called the x-axis. This would be the number line, a second number line right here called the y-axis. Talk a little bit more about those as well, but just give you an idea, okay? The x-axis is a horizontal number line. Okay. The y-axis is a vertical number line. Okay. When we put them together, they form that coordinate plane. That's what we were talking about. Quadrants are the four sectors of a coordinate I'm having a spelling issue there, plane. They are numbered with, I'll draw just a quick little schematic over here. They're numbered with Roman numerals. This would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So starting right here in the upper right hand corner, that's 1. Then we go counterclockwise 2, 3, and 4. Always numbered, or called quadrant 1, written with a Roman numeral. Okay. Then the origin is the point 0, 0, where the axes intersect. Axes is the plural for axis. Oftentimes it's also going to mark that intersection. Might just have an O written there, O for origin. Okay, it's kind of hard to make it look different than an O in handwriting, but you'll see oftentimes it'll be in italics in your book or sometimes somewhere else as well. But it's just where the two number lines intersect, each of them at their point 0. All right, an ordered pair gives the coordinates of the location of a point. An ordered pair is always written the x value first, the y value second, in parentheses, x value, comma, y value. Always like that. No parentheses, no comma, it's something else. So be sure you keep that in mind. The x-coordinate, which is that first number, tells the number of horizontal units a point is from the origin. The y-coordinate, the second number, tells the number of vertical units a point is from the origin. So basically we would move horizontally and then vertically. The ordered pair gives you sort of like a set of directions for the location of a point. Okay, so we want to graph point P, whose ordered pair is -3, 2 on a coordinate plane. So here's just a real quick walk through that. Again, here are your x-axis and your y-axis. They're slightly darker than the others. On your paper, it's probably much more visible than it is here on the screen. The first thing we want to do is we're going to start at the origin always. we're going to move 3 units to the left because it's -3. That means a movement to the left. From this location, then, we're going to move 2 units up because 2 is positive. Draw a dot, okay, and then you're going to label it point P. Okay, so there's a lot of stuff going on in this whole thing because they have all the little arrows pointing to you. Generally, though, with your x-coordinate, if it's negative, you're going to move left of the origin. If it's positive, you move to the right of the origin. For the y-coordinate, if it's negative, you move down from the origin. If it's positive, you move up from the origin. Okay. Of course, we can practice more of these in class. If you need to, please be sure to ask. Going on to my next example, finding distance on a coordinate plane. The park is 4 kilometers west of the bus station. The grocery store is 7 kilometers south of the bus station. To the nearest kilometer, how far is the grocery store from the park? Okay, if you see, the bus station is the common point they have there. So if we think of that as the corner, the vertex, where the right angle of a right triangle is located, the distance from the bus station to the park is 4. And we can use Pythagorean here. A squared plus b squared equals c squared. Where distance from the bus station to the park is 4, and that's one of our legs, we'll call that A. And bus station to grocery store would be the second leg, we'll call that B, and that is 7 kilometers. We're trying to find the distance or the hypotenuse of this imaginary right triangle. Okay, 4 squared is 16, 7 squared is 49, and I don't know the value of c squared just yet. 16 plus 49 is 65, so c squared equals 65. I want to square root that then. So the square root of 65 is 8.06, and it continues. 65 is irrational because 65 is not a perfect square. So to the nearest kilometer, this is 8. So the correct answer choice is D, 8 kilometers. Okay. You would need to use a calculator for that, or would be allowed to do that, so don't panic about the computation. So basically, those are the things we're going to be going over in this section. Please complete the quick checks. Bring to class any questions you might have. As always, you might want to refer to your textbook for additional examples and illustrations to help you as well. Look forward to seeing you soon. Thanks. Bye-bye.